Okay, I want to continue our discussion on proportions and take a look at how we can use some of the models to help students address some of the misconceptions that they have with the proportions. So I have up here the proportion 2/3 equals x over 6. And one of the very common misunderstandings that I see students see is that they realize to get from 3 to 6 we have to add 3. So then to get from 2 to x we want to add 3, and therefore they say that x is equal to 5. So one thing we can do with this is we can leave the answer as is and we can show them a model, and hopefully they'll realize that, well, that doesn't really make sense because then those aren't equal. So in this statement, this would be then saying that 2/3 is equal to 5/6. So in my model, I would probably use the strip diagrams, and there's one of the wholes. If I break that into 3 equal parts, and the second ratio is 5/6. Because they're equal, the wholes would be equal. I break that into 6 equal parts. So I have 3 equal parts and 6 equal parts. So this ratio would then say that 2 of the 3 equal parts would have to be equal to 5 of the 6 equal parts down here. And from this model, we can recognize that these are not equal. There is an extra space right here, so 2/3 is not equal to 5/6. So from that, we can then go back up and address, well, what other relationship do we see if we take a look at multiplication instead of addition? So let me change this, and we can now demonstrate to the students that, well, 3 times 2 is 6, so then 2 times 2 is 4. So what would this look like if x equaled 4 instead? And our proportion would then read 2/3 equals 4/6. Let's see through our strip diagram if that is true. So in my strip diagram, my first whole is broken into 3 equal parts. My second whole is again broken into 6 equal parts. Do a very good job of making those equal. But now when I shade in 2 of the 3 equal parts, and 4 of the 6 equal parts, I can see that indeed these are equal. So this would be a good way to demonstrate to a student and help them to understand why we multiply instead of add to make sure that our ratios are in proportion. Because the proportion means that these fractions must remain equal. These ratios have to be the same reduced fraction, essentially. Another thing that I want to look at is some of you have realized that we can use cross multiplication. So, and this might lead a little bit further into the upper grades, the middle school, maybe 4th, 5th grade, when we can really start using multiplication, division, inverse operations. So let's take a look at, I have an example written here that I wanted to look at. Let's look at the ones that we looked at before. 4 miles to 1 hour was equal to 8 miles in 2 hours. So we can continue to use the same example that we've been demonstrating with the students to look at another relationship, and that's that cross multiplying is going to be equal. If I multiply diagonal or across, 4 times 2 is 8. I can do that this direction as well and see that 8 times 1 is also 8. Maybe they want to see one more example. So let's use the other one we had with the coloring the pages in so many hours. And we had said we could color 10 pages in 1 hour. So how many pages could we color, or how many hours did it take us to color 30 pages? I have to think back, I'm sorry. We colored 10 pages in 2 hours. So how many hours would it take us to color 30? And that was 6. So we can use this example to show that, again, 10 times 6 multiplying diagonally is 60, as well as 2 times 30 is also 60. So we can see the relationship that when we cross multiply, we end up with equal products. So we end up with equal cross products is what we call them. This can be a really helpful skill for when we need to solve a proportion that maybe isn't quite as obvious of a scale factor. For instance, we went from 1 to 2, it was very clear for us to see that that was times 2. From 10 to 30, it was very clear for us to see that that was times 30. What if we have 2/12 equals x over 18? Well, this one maybe isn't quite as clear for students. 12 times what is 18? Some of them might be able to find that pretty easily, but some might really struggle because it's not a whole number. So this is where we can use the idea of our cross products to help us out. My cross products have to be equal if the proportions are equal. Therefore, 2 times 18, which is 36, must be equal to 12 times x. So this is where you can see that the students have to have somewhat of a prior knowledge on inverse operations, because at this point, I'm left with an equation that needs to be solved. So I would see that I have 12 times x. I would need to use my inverse operation of multiplication, which is division. And I can see that now 36 divided by 12 is 3. So x would have to be 3. So I hope all of these different models, with looking at transferring to percent to decimal, when we look at tape diagrams, when we look at how ratios and proportions are compared side to side, as well as cross products, I hope this has cleared up a little bit of the misconceptions. If you still have questions, please reach out. Thank you.